We spent time looking at various reactions where weak nucleophiles were added to aldehydes and ketones, and we did things like acetal formation, imine formation, and enamine formation. Now we're going to talk about the reverse reactions. And the reverse reactions of these are hydrolysis reactions. So if you think back to the reactions including acetal formation, imine formation, and enamine formation, in all of those, water was lost at the end of the reaction, and a way to drive those reactions was by removing water as it was formed. Because those were all equilibrium reactions, they're reversible. So if you were to start with the products and add acid and a bunch of water, we can do the reverse reaction. And the reverse reaction for all of these are hydrolysis reactions. So what is hydrolysis? Hydrolysis is a process by which a molecule is broken down with the addition of water. Well, we can simplify it a little bit, and basically what's going to happen is water is going to add to the molecule, and in doing so will break it into two separate species. So things like hemiacetals, acetals, imines, and enamines can all be hydrolyzed by water. That means these are all considered hydrolyzable functional groups. And we're going to add to our list of hydrolyzable functional groups later. But for now, know these four. So let's look at this first reaction that's boxed right here. In this case, let's think about it in reverse first. If you were to take this ketone and react it with methanol in the presence of acid, you would lose water, and this acetal would be the product. Well, if instead we retain our acid, but we add a bunch of water, what that's going to do is drive the reaction to the other side. So if you take an acetal, acid, and a bunch of water, now you're souping up one of the reactants, which will disturb the equilibrium and push it in this direction. So we can hydrolyze this acetal to the ketone and the two equivalents of alcohol. Similarly, if you take an imine with acid and water, we can drive that reaction to the hydrolysis products, getting a ketone plus an amine. Same thing for an enamine. Acid and water will hydrolyze it to give the ketone and amine. So we're going to look in more detail at these hydrolysis reactions, and we're going to go through the mechanisms. But before we do that, I just want to preview it for you by saying the mechanisms for hydrolysis are the exact reverse mechanisms for the formation of the product. So if you go back to your mechanism for acetal formation, if you want to do the hydrolysis mechanism, it's going to go through all of the same intermediates to get to the product. It's the exact reverse.